Hi everyone, my name is Aaradhya Srivastava, and in this video I will walk you through my Comp 380 Lab 5 on AI planning. This lab mainly focuses on planning problems using strips representation and CSP. I will go over the questions, explain key concepts, and demonstrate the AI space simulation to show how I solve the simple computing problem. So question A, what does the strips representation of an action consist of? Strips basically stands for Stanford Research Institute Problem Solver. It consists of two main components, preconditions and postconditions. Preconditions are the conditions that must be true before the action can happen, and the postconditions are the effects that occur after the action. For example, in our commuting scenario, if I take the go by bike action, the preconditions are that I must be at home and have a bike, and the post conditions are that I arrive at UFE. Question B, what is the strips assumption? The strips assumption means that only the conditions explicitly mentioned in the effects of an action will change, while everything else will remain the same. For example, if I drive to UFE, my location changes, but my car status remains unchanged, unless it is explicitly stated that it has to change. So when I drive to UFE, my location will change from home to UFE, and my car will be still with me. So, yeah. Question C, examples of constraints used in CSP planning. There are two main types of constraints in CSP planning. First, the preconditioned constraints. These ensure an action can only happen if specific conditions are met. For example, I can only take the go by bike action if I am at home and have a bike. If any of the two are not being met, then I cannot take the action go by bike. Second, the effect constraints. These determine how an action changes variables. For example, if I take the go by car action, my location must change from home to UFA. It cannot stay home. It has to change from home to UFA because I've completed the action go by car. D. What is a horizon? A horizon is basically number of steps needed to reach the goal. If the horizon is one, I can only take one action to reach my destination. Now let's move on to the AI space simulation. I will show this in the AI space simulation. I have already loaded the simple commuting problem. Let's check the default set start state for this. As you can see, it is correct because the location is home and the have bike and the have car are set to true because we need to have a car or a bike. And now let's check the goal state editor. In this, the default location is set to UBC, but according to our problem, our goal is to reach UFE. So we will change UBC to UFE. So what we'll do is we'll click on set properties, location, and we'll add UFE here. Okay. And we'll go just a second. I'll just have the move meeting controls. Okay. We'll go here and then we'll change UBC to UFE here as well. And we'll also change this to UFE and this to UFE as well. So now our goal is set to UFE. As we can see here, there is no location precondition for go by bike or go by car, as you can see. So let's create the preconditions because without the conditions, it means that we can start from any location. But according to our question, we need to start from home. So let's create the preconditions, which is that we have to be at home. So sorry. So we'll select create arc and then location, go by bike, and we'll set it to home because we need to be at home. And same for go by car, we'll do home. We'll just move it a little. Okay. We'll just move it a little down so that we can see all of these. Okay, so now it's set to home. Now we'll go through some questions before running the R consistency about the simulation. So first, what is the starting point and the goal point? The starting point is we know that it is home and the goal is to reach UFE. And second, what are the preconditions of go by bike and the post conditions of go by bike? So we'll open go by bike properties, go by bike. So here we can see the preconditions of go by bike are that we have to be at home and we need to have a bike, which is true. And the post conditions are that our location changes to UFE from home, and the having a bike is will remain true, obviously. So now we'll go to the solve tab and set the horizon to 1. It is already set to 1 because we just want to take either a bike or a car, not both of them together. So we'll choose 1 and now we'll run the R consistency. Now, as we can see here in the CSP, first let's expand it a little. Okay. Yeah, this is better. These are the starting constraints, these are the preconditions, and these are the post conditions. Um, so let's run it to remove all the invalid values, and then we'll talk about all the invalid values. So we'll do auto consistency. It is going to take a few seconds. As you can see here, already these have been changed, and this has also changed, and this is also done. It's almost finished. Yeah, so the Ottawa consistency is finished now, and let's look at the removed values. From the location SO1, the values UBC and UFE have been removed, and just the home is left because according to our precondition, we had to start from home. And for location S1, the variables home and UBC have been removed because our goal was to reach UFE. From the half bike SO1 and half car SO1, both of them, the false value has been removed and they're only left with true because our condition was to have a bike and a car. And for here, same as well, half bike S1 and half car S1, it is just left with true because obviously when we go from home to UFE, we'll use the bike or the car and we'll still have the bike and the car. So yeah, that is all for this assignment. Thank you.